Hello and welcome to another episode of AWS Cloud Bytes. Today we have a lab where we're going to launch an Amazon EKS cluster. You can look at the objective over here. The objective is to launch an Amazon EKS cluster. We're going to use a jump box to launch this EKS cluster using the AWS CLI. Things that we're going to do in this particular lab is we're going to create a IAM user with admin permissions. And then we are going to launch an EC2 instance. This EC2 instance will act as a jump box, or you can say that this is your publicly exposed EC2 instance where we want to do some administrative work. We are going to install the kubectl and EKS command line tools so that we can provision the EKS cluster. Following this launch, we are going to create an EKS cluster using AWS CLI. And then in this, we are going to create a deployment. First, we are going to create a EKS service and then a deployment followed by that. And then we are going to test the high availability feature of the EKS cluster. So let's begin. I have already logged into the Amazon console. I'm going to IAM user. Let me open the user. So the IAM user is here. We are going to create a new user. This is a new interface. So I'm going to name it as EKS user. And we don't need any kind of console access. That's why we are not going to create or check that box. Over here, we are going to attach a policy directly to the user. I'm going to use admin access policy. We need to allow our EC2 instance to perform where we're going to use this particular user. Under this context of this user, we're going to run the creation of cluster, and in order to do that, we are going to create a VPC and subnet and internet gateway and many more things as part of that particular execution. So we're going to give an admin access to this user. I'll just create the user. Once the user is created, I'll go there and I need security credentials. So I'll create an access key, and this is for CLI because we want to use this for our CLI, and we don't need to give a tag. So I'm gonna just copy and keep it for AWS configure that we're gonna use later on. I'm gonna copy the secret also. So we have both. We can download also, but I just copied it. Now we're going to create an EC2 instance. So we'll go to the EC2. Let me open it in a new tab. EC2 is here. I'll go to the launch instance. We don't need a huge machine, so we're gonna just stick to the free tier. I'm going to name it as a jump box. And I will stick to the AMI that we have. T2 micro is good. I'm going to create a new pair, key pair. And this will be EKS login. I'm gonna create this key pair. Save it on the desktop. We need the access to this particular EC2 instance from internet. So I'm going to enable the auto-assign public IP. And apart from that, I guess rest is good. So I'm going to launch this instance. Okay, let's look at the status of this instance. Usually takes a couple of minutes to launch the instance. Let me remove the filter. Oh, it was pretty fast. Now we have the instance running, and we can connect to the jump box or the EC2 instance in public subnet. Okay, we are in the EC2 instance. Let's look at the AWS version. So we can see we have the CLI version of 2.1718. Because it is already on version 2, we don't need to upgrade. If it is not on version 2, we need to upgrade this. Now we're gonna configure the AWS. So the key pair that we copied, So access key I have provided, and then I'm going to provide the secret, and this is going to be US East 1 and JSON. So let me clear the screen. Now we have the AWS configured. Let's go forward with the installation of kubectl command line interface. So in order to get the kubectl, I am going to use a curl command. You can see that I'm using a curl, and then this is the location where I can download the kubectl or kubectl. This is downloading kubectl or kubectl, as you like to call it. Once you are done with that, I'm going to apply execute permission to the binary. Now, once this is done, I also want this binary to be in a path folder so that I can execute this binary from any location. So what I can do is I'm going to paste this command. You can see that I'm creating a directory and then copying the files from kubectl to the bin, and also putting that path into home bin. So let me do that. Okay, that's done. Now kubectl has been installed, and we want to see if it is working. We want to check the version. So I'm gonna run this command to see if it is working. You can see client version, and there is a version v1 16.8. And now the next thing that we need is EKS-ctl or EKS-ctl. So I'm going to use another curl command to download this. You can see I'm using curl command, and the location is from a GitHub. And once it is downloaded, it is put into a temp directory. That is downloaded. Now we are going to move this from the temp directory to a user bin, and now we want to check the version of EKS-ctl. You can see it's 0.199.0. Now I think we are ready, given both the CLI tools have been configured, AWS has been configured. Now we can go ahead and create a cluster. I'm gonna copy a command, and I'm gonna explain this command. This command is EKS-ctl create cluster. The name of the cluster will be dev. The region will be US East 1. The zones are, you don't need to define it, but you can if you want. It's not required. These are optional. Node group name is standard workers. Node type is T3 medium. This is the EC2 instance type. And then you have nodes, number of nodes. We have 3. Node minimum is 1. We need minimum 1 node and maximum 4. And these are going to be managed. Let me put that. Now it is running a CloudFormation template behind the scene, and it is deploying the stack. We can look at the CloudFormation. Let's go to the console, and let me open CloudFormation and open that into a new tab. It usually takes 10 minutes to run the stack. You can see there is a new stack over here, and you can look at the resources. Either the creation is in progress or it is completed. You can see the VPC. You have the VPC gateway, subnets, public and private subnets, route tables. Control plane is in progress. The NAT gateway is also in progress. Internet gateway is created. I can see all the events as they are progressing. So that's going to take some time. I'm gonna pause the video and come back once the cluster is up and running. Okay, perfect. So it took like more than 10 minutes, and you can see the EKS-ctl dev cluster. The stack is now completed. Let me refresh this. It shows completed, but yeah, okay. This is all completed. And if you look at the EC2 connect, it was waiting for the stack to be completed, and you can see that these two are both completed. Okay, let's look at the cluster that has been created. Let's go to the EKS. I'll go to EKS, and open that in a new tab. Let's go to the EKS tab. You can see there is a dev cluster. Let's click on that and let's look in the compute. Okay, looks like it is still work in progress. There is no node group, which we were expecting. Let's wait for another minute or so. If you look at the instance connect, you can see that it is starting to create the node group for standard workers. And you can, if you remember, this is what we gave, node group name, standard workers. So that is work in progress. And if you look at the CloudFormation stack, there is a third stack, which is now work in progress. Creating the node group, still work in progress. Let's wait for another minute or so, and then we can look at the node groups. Okay, it just took like a couple of more minutes. You can see the third stack of node group is completed, and if you look at the EC2 instance connect, you can see that it is now available. So if you go to the clusters, and I think I need to refresh the cluster, you can see there is a node group, standard worker, and there are, as per the configuration that we set, this is the desired number, this is the minimum nodes that we need, and this is the maximum nodes that we need. In the capacities on demand, these are the subnets where this cluster is attached to, and this is the IAM role. Auto scaling group name is also created based on these configurations. Let's go back to the EC2 instance connect. I'll clear the screen. Because we are done with the initial creation of cluster, we can just check the cluster. You can see there is a dev cluster in US East 1. In order to allow our cluster to connect from here, in order to enable that, we need to trigger this update. So what we are saying is we're going to update the kubeconfig and giving the name of the cluster in the region. So this additional context has been applied. Now we need to create a couple of deployment and service files. So let me show you the deployment file and service file. First, we are going to create a service file. This is how the service file will look like. This is a load balancer, and this is nginx service. It's going to be deployed as a service. I'm gonna copy this and create a file here, paste it, and you can see a new file has been created. I will also create a deployment file. This is okay. Before I create the deployment file, let me show you the deployment file. So this is the deployment file. It's a kind of deployment. Its name is nginx-deployment. 3 replica, environment is dev, and there is additional label of dev. We are using nginx image, and the port is 80. So let me copy this, paste this over here, and then write the file. Let's see. Nginx deployment. Both the files are available. Now, first of all, we're gonna apply the service. This command kubectl or kubectl apply, and the file name is nginx-svc file. This is the first file that we created. We're gonna apply that. You can look at the service, and you see there is an external IP here for nginx service. It's a load balancer. This is IP address, and there is a DNS. We are going to copy the DNS and keep it for future use in this particular lab. Okay, let me minimize this. Okay, this is done. Now, once the service is there, we need to create a deployment. So what we're going to do is we're going to apply the next file which we created, nginx-deployment, which is going to take the nginx image and create a deployment for us with 3 replica. This is the deployment file, 3 replicas, and using the nginx image. So kubectl or kubectl apply the file name. Now this is done. We can look at the deployment. There are 3 deployments, all 3 are ready. Now look at the, let me clear the screen. kubectl get pod. You can see there are 3 pods, all 3 are running. kubectl, so kubectl kubectl get replica sets. There are 3, and desired is 3, current is 3, ready is 3. Now we copied that load balancer DNS. So if you want to take a look at the output of the DNS, just copy that DNS that was created, and we can do a curl command with the DNS name. You can see there is a welcome to Nginx. This is hosted by our EKS cluster. We can also go to the UI and execute the same command over here. I'll continue. This is an Nginx server running. So let's go to the EC2 instance where we launch the EC2 instances, and you can see that one of them is our jump box and rest is standard worker node, these 3 nodes. Now if you want to test a high availability, we want to stop all these or terminate these instances. Let's stop these instances apart from, let me select all and remove the jump box from this. So we want to just shut it down. So we'll stop these instances. And once these instances are stopped, we'll see that the EKS will start launching new instances to keep the service running. So if I stop these instances, okay, so we are stopping 3 instances. Let's go back to the EC2 connect and we'll say kubectl get node. This has been running, but and let me see, kubectl get pod. Still not reflecting here. Let's see if the instances are, 1 is stopped, 2 is stopped, and 3rd one is stopping. Let me check the node again. So you can see the 3 nodes that were there. It's 10 minutes. The age is 10 minutes. And you can see they are not ready, which means in order to run or keep it running, given the auto scaling group that we have created, you will see the new instances are up and running. So if you look at the pods, these are still showing 4 minutes and 55 seconds. Let's wait for a couple of minutes. I'll pause the video. Okay, I just refreshed and you can see there is 1 new EC2 instance, dev standard workers node. This is currently initializing and the status check is initializing, the instance state is running, and the jump boxes was running. So we are on the jump box. And if you look at the refresh, you won't see any issue here. You should be able to reach to this page again because that 1 instance that is up and running is going to serve it. Let's go to the EC2 connect and see how nodes are. So you can see there is 1 is ready, 3 are not ready, scheduling disabled, status is also there. The minimum requirement is 1 and the maximum is 4. You can see 1 pod is terminating and 3 are running. We can also run a curl from here. Let me go and bring the curl. You can see the curl is still giving you nginx HTML. So let me clear this. This is the end of the demo, but before we close, let's delete the cluster. Otherwise, you're gonna pay. This is going to be charged. It's better you delete and clean up anything that you're running. So EKS cutl, delete cluster, cluster name, and the region that we have provided. So that's now deleting the cluster, and this is going to delete everything that we have, including the deployments and the service that we created. This is the end of the lab. If you have any questions, just let me know, and feel free to provide your comments or things that you want to take a look in the long run. If you like the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host, Bhavesh Kumar, signing off. Thank you, guys. Bye.